Let's take this problem. This problem says, just one moment, this is the problem. The problem says that the pulleys in the figure are identical. Both pulleys are same, and both of them have the radius r and moment of inertia I. Find the acceleration of the block M. Now, look at the picture very carefully. This is a picture from your textbook. This block M, capital M, it is shown in your textbook diagram downward, lower than small m. It gives an indication that capital M is going downward and small m is going upward. And in textbooks also, always, the heavier body is given the capital legend, capital M, and smaller body is given small m. But of course, when you sit for competitive examinations, these things are very clearly clarified in the question itself. It will be written there that capital M is heavier than small m. Okay? Here we have to just understand it from the diagram. And both these pulleys have some moment of inertia, so both those pulleys are part of the system. Let us say this pulley 1, let us say this pulley 1, and let's say this is pulley 2. And since capital M is going downward, of course, this pulley is rotating in anti-clockwise direction, and this pulley is also rotating in anti-clockwise direction. And there will be a tension T1 here in the string, tension T2 here. T1 and T2 is different because of the moment of inertia of this heavy pulley. Similarly, T2 and T3 will be different because of the heavy momentum of this pulley. In your earlier chapters were kinematics, where all pulleys were said to be light pulleys. So all these tensions, T1, T2, T3 in those chapters were same. Now it is different. Now let us consider a free body of the mass capital M, right? Consider free body diagram of capital M. If you consider free body diagram of capital M, this capital M is moving downward. So its downward force is capital Mg. So capital Mg minus upward tension T1 will be equal to capital Ma. Let's call it equation 1. Consider pulley 1. Of course, if you consider pulley 1, that means you are considering its rotational motion. The torque produced by the pulley 1 is, not by the pulley 1, torque produced by the tensions on pulley 1. The pulley moves in anti-clockwise direction, and the anti-clockwise torque is produced by T1 multiplied by radius r. So T1 minus T2, because T2 produces the torque in other direction, T1 minus T2R will be equal to I, moment of inertia, into alpha. Alpha is the angular acceleration of this pulley, but alpha is, we straight write A by R. A is the tangential acceleration A. This is the same acceleration of the capital M. So we straight write A by R. So therefore, from here you get T1 minus T2 is equal to IA upon R square. This is, not R2, T1 minus T2 divided by IA by R square. Let's consider equation 2. This is equation 2. Next we go to, let's say we go to free body diagram small a. Consider the free body diagram of small a. Small m moves upward and its upward force is T3 minus downward force is small mg. T3 minus small mg will be equal to upward acceleration and mass. Upward acceleration and force will be equal to ma. Upward mass into acceleration ma. Let's consider, let's say it is equation 3. Similarly, consider pulley 2 for its rotational motion. If you consider pulley 2, it's for its motion. T2 is trying to rotate it in anti-clockwise direction. So T2 minus T3 multiplied by the radius of the wheel R is equal to IA by R square is equal to IA by R square. Sorry, it is equal to IA by R, not IA by R square. IA by R. From here we get T2 minus T3. T2 minus T3 is equal to IA by R square. Let's say this is equation 4. T2 minus T3 is IA by R square. So now if we add equation 3 and 4, add equations 2 and 4. Equation 2 is T1 minus T2 is IA by R square. And this is T2 minus T3 is IA by R square. If you add them, then you get T1 minus T3. T1 minus T3 is equal to 2 IA by R square, 2 IA upon R square. Let's call it equation 5. So here equation 5 is the relation of T1 minus T3. There is another way of finding T1 minus T3 by using the kinematics idea, using these tension values and mass. From equation 1, go to equation 1. I take another color of the pen that will be easy for you. From equation 1, we get T1 is equal to MA minus T1 is equal to mg minus MA. T1 is equal to capital MG minus capital MA. Similarly, from equation 3, we get equation 3. This was, we forgot to write it them there correctly. From equation 3 was T3 minus mg. T3 minus mg. So from equation 3 we get T3 is equal to small mg plus small ma plus small ma. Now from these two equations what we get? We can get another value of T1 minus T3. So we get T1 minus T3 is equal to capital MG minus capital MA minus small mg minus small ma. This is, say, equation 6. Then we have two relations of T1 minus T3, equation 5 and 6. Now we just compare these two equations. So we write from equation 5 and 6, we can write that's 2ia upon r square, 2ia upon r square is equal to capital MG minus capital MA minus small mg minus small ma. We take all part with a on the left hand side. These are the three parts. So from here we get a into capital M plus small m, capital M plus small m plus 2i upon r square is equal to, on the right hand side we have capital M minus small m g. Fine. So from there we get acceleration of the body A, of body M, acceleration A is equal to capital M minus small m g divided by capital M plus small m plus 2i upon r square. So this is the relation that they want you to find out. Okay. Next, we shall go to the next problem.